scale from small to medium to very large networks, like up to millions of users. They are looking for a network that can cover large areas, long range. Maybe the main key is less access points per square kilometer, because less access points per square kilometer turns very quickly to a better business case to the entity that is putting out this infrastructure. Of course, the carrier is looking for a smooth rollout. They want technology that you can install fairly quickly, commission it easily, and then it will work with very good availability, uptime, and so on, good network management system, and so on. And when specifically we look at carriers from the mobile industry that are looking for connecting these Wi-Fi networks into the mobile network, they are looking for a technology with open standards, very easy to integrate with existing core networks. If we look at the user perspective, well, users would like to have a Wi-Fi network which is very easy to connect to, should be seamlessly. There is this hotspot 2.0 standard, which is written here, and I will describe in more words later on. But in a few words, hotspot 2.0 is going to automate the connectivity of a new user to a Wi-Fi network, similar to the way that is being done today with cellular technology. Of course, the users would like to have a fast, high-capacity network, and we should never forget security. So this is just, in few words, what is a carrier-grade network, Wi-Fi network. In this slide, I try to put a diagram presenting the outdoor Wi-Fi market with its different levels and different types. So we see all these private and vertical networks on the lower side. Then we have these wireless ISPs, and on top of that, these smaller areas are for the carriers. There are the fixed carrier access service, and there is the cellular offloading. Now, all this market is supposed to be a few $1 billion market, including enterprise, consumer markets, and so on and so on. But if you look at these small areas of the carriers, this is a fairly small market, preferred to be today less than $500 million market, maybe $400 million market. But this is a very fast-growing market. Well, 2-3 years ago, this market was almost zero, and it is expected to grow very fast to about $1 billion in 1 to 2 years. And this is the market that we are talking about today. Well, how is this market growing so fast? What is fueling this market? So the main driver is us, the user. The users are getting more and more used to using Wi-Fi networks. Wi-Fi networks are out there. They are it is low cost and unlicensed band infrastructure. It's easy and fast to deploy by the operators. Half of the smartphone usage today is being referred to being done by Wi-Fi. When we say smartphone, we mean cellular phone. And the data usage of cellular phone, half of it today already is being done over Wi-Fi. We all know that there are already Wi-Fi only devices, such as tablets. And this is another indication that users are looking for Wi-Fi. Well, Wi-Fi is now starting to be referred to as a better user experience when it is there. When it is there, and users are looking for data now, anytime, anywhere, fast, reliable, and good Wi-Fi infrastructure is a good solution for all that. And this is one of the main drivers for this growth. In this slide, slide number 8, you can see a very interesting diagram done by Cisco a few months ago. Well, this slide shows that although today most of the data is being used in fixed network. Fixed network is this light blue in the middle. But if you look at the year 2015, at least according to Cisco, by this year, most of the IP data will be used in Wi-Fi networks. And this is a very significant indication. Wi-Fi networks will transfer more data than ADSL and cable together by the year of 2015. So this is a really fast-growing market. Wi-Fi is strategic to cellular operators. Why? Well, we probably, most of us see these type of statistics and indications all over the place. Like from Juniper, we see that 60% of the mobile data will be offloaded to Wi-Fi by 2015. You see here some indication about the number of hotspot sites. The third bullet indicates the number of hotspot connections in the AT&T network, which is growing very, very fast. But I think the most interesting data in this slide is the fourth one. According to the WCAI industry report from a few months ago, 47% of mobile operators think that hotspots are crucial to enhance their user experience, their customers' experience. Well, if you have done this research 2 or 3 years ago, I would say this number would have been almost zero, because mobile carriers looked at Wi-Fi as something which is not serious and they will not even try to use. But today, 47% of these operators, meaning almost half, think that this is something which is crucial for their end users, their customers' experience. And this is a very significant data. If we try to open our mind to more advanced services and opportunities for operators using Wi-Fi, well, the first one would be location-based services and indoor navigation. We all used to use GPS services almost on a daily basis. We want to know where we are. We want to navigate. We want our applications to share our location with our friends. Young people want to share with their friends everything that they do or see or visit real time, all the time. But what happens when we are indoors? GPS will not work. The same goes when we are in the middle of a city with very high-rise buildings. Well, there are multiple technologies that are competing these days in order to offer location-based services such as navigation and advertisement and friend finders and so on for indoor environments. And Wi-Fi is one of the most significant ones. So this is one. Second is managed Wi-Fi services. We see more and more examples of cellular operators putting up Wi-Fi networks and offer these services to private organizations as a managed service. These private organizations can be university or college campuses. They can be a business or enterprise campus, and so on and so on. Another example we see more and more often is wholesale, meaning carrier of carrier. So this one carrier puts up a network, a Wi-Fi network for its own usage, but this carrier can offer capacity on his network to other carriers. And Wi-Fi equipment should support these type of capabilities. Let's look a little bit more closer at metro hot zones. What is it and what are the relevant challenges? So when we say metro hot zones, actually we mean larger areas. They can be large indoor areas such as big malls or airports, terminals, and so on. But it can be also outdoor areas like central areas in the city, business areas, and so on and so on. One of the main challenges, I would say number one challenge in this environment for Wi-Fi is the heavy interference. The interference level when you go out from the indoors to the outdoors, the interference level is completely different. Sometimes you can experience tens of Wi-Fi networks operating in the same area on the same frequency, and your system has to cope with that. Long reach, non-line of sight, when you go outdoor, when you want to cover a street, a neighborhood, you will have many spots which are further away, which are on a non-line of sight condition. And if you want to have a reasonable network with reasonable number of access points, then your system should cope with that. Of course, we all know the regulation that limits the power for a Wi-Fi system. Wi-Fi networks cannot use power levels such as licensed network like a WiMAX and cellular technology, and this is a challenge. High multipath delay spread, well, there are many obstacles, many passes for the energy, and this is something that the system should cope with. The environment is dynamic. People are moving, trucks, vehicles, sometimes even foliage of a tree is moving. And in order to get good condition, your system should be able to address that. And last but not least, indoor penetration. We see more and more carriers that are looking for a network that can cover from the outdoor, not only the outdoor, but also the indoor, in order to save the deployment of many, many indoor units. So after we see the different challenges, let's look at the requirements that are being derived from these challenges. The most important one is beamforming. I would explain in a few words what is beamforming in the next slide, but in general, beamforming is a technology that allows a better link budget in a specific given environment. And better link budget means, of course, better reach, better coverage, better capacity, and so on and so on. Next requirement is robust interference in unity suite. Well, the technology should address this high level of interference that I explained, that I described earlier, because we are talking about systems that operate in an unlicensed band. And a carrier, specifically mobile carrier, he cannot allow his users to experience very bad service. Okay, so good interference and unity mitigation technology is a key. High MIMO level, well, without getting into too many details about what is MIMO, multiple in, multiple out technology, high MIMO level means better throughput, better capacity. Today we see more and more systems of 3x3 MIMO and even 4x4. And this is all about getting more capacity, more bandwidth out of the system. Reliability, of course, is a key. And the system should be very reliable in different conditions, different weather conditions, different environments. People are moving, trucks, winds, rain, and so on and so on. The carrier should look for a system which operates in 2.4 and 5 gigahertz band, because we see more and more 2.4 being congested, being interfering severely. In some areas, it's better if the system can also use the 5 gigahertz band. It's a larger band with better capacity and sometimes less interference. And, of course, easy to deploy and scalable system, we discussed that. What is beamforming? Well, in just a few words, without getting too technical, as you can see in this flash diagram, beamforming technology is actually a system that uses multiple radios with multiple antennas. These all radios are transmitting the same information at the same time, at the same frequency, but with a slight shift of phase of a few microseconds between them. And this slight shift of phase, these slight delays, are calculated per packet, per user. Because this is done per packet, of course, it has to be done on a hardware level. And because it is done per packet, it actually adapts the path, the energy, according to moving objects and changing environment. And all these calculations of these phase delays are being done in a way that the energy will have the optimal superposition on the other side. So if, as been seen in this diagram, if the beam has 3 or 4 or maybe 30 or 40 different ways to reach from the source to the destination, the calculations will be done in a way that the energy will have an optimal superposition of all these 30 or 40 beams. And this trick, this technology, from our calculation, is actually adding about 8 dB to the link budget, and 8 dB is a lot when you go outdoors. Of course, this technology can also focus the energy, and it is done on both sides, downlink and uplink. Because this energy is focused, this is one way of coping with interference. Because it is done per packet, as I mentioned earlier, it tracks movement and it tracks noise variations of the link budget of the wireless domain. And as we see in this diagram, beamforming actually exploits multipath and is not affected negatively by it, but really uses it to its own strength. And this 8 dB that I mentioned, together with a good complex advanced antenna array of 12 dBi gain, well, these are 20 dB that you can add to the link budget, which is really a difference, really a big difference. Going on, I just want to share with you a few results that we have from drive tests that we are doing with beamforming system all over the world. Like in this diagram, what you see in the right side is a map, is a Google map, which is being derived from a coverage tool that we developed. And you can see there is this color bar, color scale. As you can see, the color represents the throughput, the actual throughput that was sent from one side to another. As the color is more red, the throughput is higher, and so on. This specific test was done in a suburban light interference environment. You see that the access point is here. This mentions that at 70 meters from the access point, we got 134 megabits per second. This is a location which is 93 meters from the access point, but in deep indoor. You see, this is the window. This is the entrance to the indoor building. This is the client, the laptop. You see 34 megabits per second in deep indoor, outdoor to indoor penetration. A bit further away, 300 meters, you see 60 megabits per second. Well, these are very nice throughput figures, usually figures that you will not experience from a Wi-Fi system. Another example, this one from a country in Asia. This is a dense urban environment. You see this picture, very high buildings and high interference. And you see from these circles represent the distance from the access point. This is the access point. Once again, you see that even when you get further away, 200 meters, 300 meters speed, you get very nice throughput figures from a beamforming Wi-Fi network. This slide shows on this coverage map the difference between a beamforming Wi-Fi system and a standard Wi-Fi system. As you can see, these colors represent the area which is covered by one access point. You can see that this area on the left side is significantly bigger. From our experience, beamforming Wi-Fi provides 50% greater coverage and capacity versus a standard system. And of course, as larger the area is, you need less units per square kilometers, and this turns out to be a better business case to the operator. Okay, we discussed a little bit about what are the trends in this market, what are the challenges, and what the technology can bring, what values the technology can bring, can add to a system that operates in these challenges. Let's look a little bit into mobile data offloading networks. Well, in this slide, what I wanted to share with you is that the standardization, the technology standardization bodies have been dealing with the integration between Wi-Fi and cellular networks for quite a while. In 2004, the first standard addressing this Wi-Fi integration with 3G networks, the 3GPP standard body. It was a bit ahead of its time, but it still addressed the SIM authentication, meaning a smartphone with a SIM will be authenticated and therefore allowing the 3G operator to be familiar with its own subscribers. It took up to 2010, about 2 years ago, to have this integration standardized for LTE, and probably in the future most of the LTE networks will use this flavor of the standard from 3GPP. This was the first time that the standard addressed common service delivery. I will show you in a diagram in a minute. Common service delivery meaning actually that users from Wi-Fi or from LTE network will be able to enjoy the same services from the core of the operator. Services such as downloading clips or dating services or whatever. Mobility and roaming was addressed in this standard as well. The last bullet, I think, is maybe the most important one. Wi-Fi, the WFA and the WBA are working in the last few quarters on Hotspot 2.0 standard certification. Well, I promised a few words about Hotspot 2.0, and actually Hotspot 2.0 is something which is going to improve significantly the end user experience using a Wi-Fi network. So when imagine you are an American citizen, imagine you fly to India, you get off the plane, you turn on your smartphone, and after 1 minute or two, your smartphone will start to operate. You don't have to do anything. Your smartphone will be able to communicate with his base station in India and with the network, and they will find together the best network that has the best agreement with your home operator, and so on and so on. But if you step out of the plane further away and you get into the terminal and you open your laptop or your Wi-Fi in the smartphone device, then you get 10 or 20 Wi-Fi networks with different names, strange names, and you have to choose you have to choose between them by yourselves. In many cases, it's a trial and error process, which is cumbersome and not always very easy to do. Well, this is exactly what Hotspot 2.0 is trying to solve. This Wi-Fi experience will be automated. There will be a communication between the smartphone, the end device, and the access point, and the hotspot owner, and they will all communicate on and review the available Wi-Fi networks and choose the one with the best capacity and the best load and the best agreement with your home operator. And this is planned to be in the middle of this year. So all these standardization bodies are handling this integration between Wi-Fi and cellular networks. If we try to ask ourselves what are the main requirements from an offloading system, well, the first one I would say is the AAA integration. You want the user to be known when he enters into a Wi-Fi network. You want the user to be known to the carrier, to the mobile carrier. The user doesn't have to put his credentials again, and it should be a seamless experience. Carriers are looking for minimizing the backhaul, meaning if it's possible, take some of the data directly from the Wi-Fi network to the internet and not pulling it up through the backhaul of the cellular infrastructure. The third bullet is a bit tricky. Some carriers are looking to minimize the core load, meaning don't get all the traffic from the Wi-Fi network to the cellular core. Some carriers are looking for the opposite. They want to use the existing code and the existing investments to offer the same advanced services, that the cellular customer is enjoying, they want to offer them to the Wi-Fi customer. And the system should address both directions. Of course, end-to-end is security, of course, hotspot to the zero as we described earlier, and so on and so on. Let's look at two different topologies for a Wi-Fi mobile offloading network. Well, in this diagram, slide 21, what we see here, this is the cellular infrastructure, and this is the Wi-Fi infrastructure. These are the users with their various devices, and this is the mobile core network. So in this topology, which is referred sometimes as local breakout concept, the users are authenticated using a SIM or MAC-based authentication, but their data will most likely go directly from the Wi-Fi cloud to the internet. This is why it is called sometimes local breakout. So data will not get into the cellular core. This is the Wi-Fi cloud. Usually there will be an access controller that will be controlling this cloud and will be diverting the traffic of the users to the internet. Sometimes this access controller can be a distributed access controller inside the access point, the base station of the Wi-Fi system, and not centralized as seen earlier. And there are systems of both flavors. The second concept, the second topology, is sometimes referred to as tunneling concept. In this topology, here, there is a device, probably the access controller device, which will have to make a decision. Some traffic will go directly from the Wi-Fi network from here to the internet, as we saw in the local breakout topology, but some traffic will go from the Wi-Fi through a tunnel to the core network of the cellular carrier. The real advantage of this path is that these servers can offer the Wi-Fi user the same experience as the mobile network offers. Sometimes these services are very nice. The challenge here is that here there is a device, this access controller, that needs to look into these packets, referred to as packet inspection or deep packet inspection, and decide which packet should be sent here and which packet should be sent here. In this slide, I try to make a very general comparison between these two topologies. As you can see, the main difference is here. Service continuity means that the user that is enjoying the service while he's at the mobile network, when he goes into the Wi-Fi network, the user can continue enjoying this advanced service. For that, we need the tunnel topology. And the tunnel topology supports better mobility between Wi-Fi and cellular and back of users. Most operators today are using the local breakout, but some of them are already talking to us about the tunnel topology. Usually it will, mobile carriers will wait to the LTE network before they go to the tunnel topology, but this is probably a sure thing that will happen in the future. I tried to put just one case study. This is the Seoul International Airport. The entity that put this network up in the airport is a tier 1 operator from this country. They use 27 access points or base stations, as we refer to them, to fully cover the whole airport terminals. And what the topology that they're using is that the users are SIM authenticated, and this system is using multiple SSIDs. Multiple SSIDs actually is a network, a Wi-Fi network that appears to be like few networks. When you open your laptop, you can see several Wi-Fi networks, but they can all originate from the same access point. It is called virtual access point. And one of these networks will be belonging to this tier 1 operator for its own customers. but they are doing also wholesale. So they are selling capacity to other operators, like a carrier of carriers, and they're also selling capacity to the terminal itself for the terminal staff. In this last chapter of this presentation, I'd want to touch very generally a few ideas of how Wi-Fi can really generate money. I would say this is a good question. Well, carrier-grade Wi-Fi business models. Operators must rethink the business model when they look at Wi-Fi, because traditional thinking was Wi-Fi should complement the mobile infrastructure investment, because there is too much data, the mobile infrastructure cannot cope with this demand of data. So part of this problem can be addressed by Wi-Fi. Usually this was a service that mobile carriers would use in order to reduce and prevent the churn of customers when they didn't get too good of a service, too good of a data service. Usually when they started using like iPhones and other smartphones. Sometimes this service was on a pay-per-access, but more and more we see that customers are not that happy of paying for Wi-Fi service. And if the customers are not paying for Wi-Fi service, it's really difficult to make money out of it. So new ways, new thinking. How can we make money of network when the people themselves, they don't like to pay money for Wi-Fi access? One example we see more and more, capacity wholesale. One operator is putting up a network that is selling capacity to other operators. These other operators will actually use it for the same reason, in order to reduce the load on their own network, and for that they will be willing to pay. Managed Wi-Fi services, the one carrier, one operator puts up network, but then he sells a managed Wi-Fi network to a private organization, as we described earlier, like a college, a university campus, an enterprise campus, and so on and so on. Advertisement, more and more we see business models that are succeeding to create money from advertisement over a Wi-Fi network. And I want to bring one case study here, one example of this new business model. Well, we have this customer, this operator, which has put up a network all over the city. And this network is actually offering service to two types of users. One type is this customer, this service provider. He is selling capacity to the mobile service, the operator, the MSO. And these end users of the MSO, they will be authenticated based on their SIM, and this service will be bundled with their own mobile service. For the churn prevention we discussed earlier. The second network, the second SSID of this service provider is a free public access network. So customers are not paying for accessing, for Wi-Fi access. And this service provider, whenever someone wants to register to his service, it's a free Wi-Fi service all over the state. So people are interested to register. When they register, they are being asked a few questions, like age, sex, and maybe one or two more questions. Then this service provider, he is selling spots for ads, for promotion to companies. And because this service provider, he knows a few details about these end users, and he also knows where they are according to which base station, which access point, Wi-Fi access point they are connected to. Then he can sell these services to companies. Imagine a Starbucks company or a pharmacy company, and the end user will get only a few ads here and then, not too much, not too many. And some of them will reach this end user when he is in the spot which is more relevant. And this specific service provider is doing it very successfully. The next slide, just a schematic diagram showing that the same Wi-Fi system, the same Wi-Fi access point base station is serving the MSO customer, but also the free public Wi-Fi type of customer. And in this case, we see a situation where a customer can really make money, although the customers are not paying for the Wi-Fi service. Okay, so we covered most of the content I plan to deliver. Just to summarize, main points we discussed today: carrier-grade Wi-Fi market is growing, and it is growing very, very fast. This is one of the fastest growing markets in the communication industry today. Wi-Fi is a real game changer for mobile service operators, and more of them are looking at Wi-Fi as something that will solve their problems and maybe even create real value. Besides basic access, Wi-Fi really brings new opportunities, new challenges, new innovations, and new business models. Before we end, I want to say a few words, just a couple of slides about Wavion carrier-grade Wi-Fi, just a snapshot. So our target is to provide a wider coverage, higher capacity, and lower cost Wi-Fi solutions for carrier-grade broadband applications. So this is about carrier-grade networks. We are not an enterprise or consumer-grade network deployed in many places all over the world. And our position is to supply a solution, not just a product, meaning access, backhaul, in various frequency bands, in various standards. And the type of customers I've seen here, carriers, ISPs, governments, and so on, for various applications. Because once you have a very reliable Wi-Fi infrastructure in an outdoor environment, one can do many, many things, many interesting applications on top of it. One slide about selected customers. For example, in the upper left-hand side, Tata. Well, Tata is a very large company in India, and TTML is a mobile division in Tata. They used our system to cover an area which is called Navi Mumbai, in the middle of Mumbai, the most dense area. And 50 square kilometers were covered by 220 base stations, 220 access points. This is a ratio of about 4.5 base stations per square kilometer. And this is a very overwhelming figure. In standard Wi-Fi infrastructure, you would need 2, 3, or 4 times more units per square kilometer. And maybe just one more case study, like this San Luis province in Argentina. This is a very large area covered with a few hundreds of base stations with a blanket coverage. And you see the deployment is very easy on the light pole, on the electricity pole. And without getting into more examples, this is the type of customers that we are serving. Thank you very much for listening.
Thank you, Ulik. That was an excellent presentation. This would be the beginning of the question and answer period, and I understand we have 6 questions already. Feel free to type in your questions as we speak here. Give me 1 second so I can see the questions. Okay. Are there smartphones that can support the 5 gigahertz access band? That's an excellent question.
So the question is, are there any smartphones that support 5 gigahertz band?
Yes.
Yes, more and more devices are coming out to the market that support 5 gigahertz band. This includes the various types of smartphones. For example, the iPad the Apple iPad. The iPad 1 was only supporting 2.4 gigahertz, but the iPad 2 is already supporting 5 gigahertz. Some of the laptops are already supporting 5 gigahertz band as well.
I see. Okay. How can you avoid interference at 2.4 gigahertz? I think you may have addressed some of that with the smart beam, but if you could elaborate on that.
Yes, well, I don't think you can avoid, but you should try to avoid the effect of interference because it is unlicensed band. There is no way to avoid. One operator is putting up a network in a specific area. Tomorrow, another operator can put up a network in the same area. So you should try to use a system that mitigates, that is partially immune, or as much as possible immune to interference. And I would say one thing is beamforming technology, as I mentioned earlier, which is actually focusing the energy between the access point and the client in a way that is less affected by noise from other directions. Other technologies that we are using, such as we are investing a lot in the algorithm that chooses the rate of each packet between the access point and the client and vice versa. Probably you know that Wi-Fi technology supports multiple rates, and the system is trying a rate, and if the packet is not reaching the other side in a good way, the system will lower the rate and try again, and so on and so on. If you want a system with good capacity, you want to do it right at the first time. So we are using a real-time algorithm that chooses the best rate per packet in order to reduce the read transmissions. And additional technologies such as controlling the noise levels and the noise figures of the radio in real time per packet, and so on and so on.
Sure. You think that all of that would really increase the probabilities of interference actually happening. Next question is a good one. Do you have a solution for DOS attack? I'm not sure what that acronym is.
Well, DOS attack is a denial of service attack.
Okay, thank you.
Yeah, so denial of service attack should be addressed mainly by the carrier from the core side. Our units that are deployed out there, you cannot reach them from the outside of the network. You cannot attack them or do this denial of service attack. Of course, other parts of the core network of the service provider are exposed to such attacks, mainly from the wired side, not from the wireless side, and this should be addressed over there. We are not handling these type of attacks.
And how would that, the second part of the question is, how would that affect the performance of commercial CPEs?
Could you repeat the question about these commercial CPEs? What is the question?
Yeah, it appeared to be part two of the same question, I'm pretty sure. How does this affect performance of commercial CPEs?
From denial of service
attacks? I guess denial of service attacks is part two of a two-part question. Is there any performance degradation? What I take away from that?
Well, we are focusing on carrier grade equipment, base stations and CPEs. The CPE, as I said, you cannot reach it from the wired side, and you cannot reach it also from the Wi-Fi side if you are not the base station. So the CPEs, our CPEs are not exposed to these type of attacks. Regarding the various CPEs in the market, well, if you put them in the public network, they are exposed to such attacks, and we are not addressing that. It should be addressed by maybe the CPE maker, or if not, it can be a weak point.
Very good. Next question is, are features such as CSFD and EHRPD available on Wi-Fi offload?
I think I didn't hear very well the acronyms. Could you repeat them?
Yes, features such as circuit switch fallback, CSFD or EHRPD available in Wi-Fi offload?
I'm not familiar with these features. If these questions are sent, I can address them to the specific person that asked offline. I'm not familiar with this feature in the Wi-Fi network.
Okay, I can submit that to you offline, Ulik, and we can do that by email. The next question was, is this presentation available to download, which I would view as a compliment, Ulik. To answer that question, these webinars are available shortly after their event for replay, and they're consistently available at the WCAI website. Is their advertisement system built into the solution, or does the ad insertion happen elsewhere in the core? In other words, the commercial insertion aspect of your presentation, how is that done? Is that part of your package, or is that something that the operator has to implement separately?
Which part of the presentation are you referring to?
The commercial insertion, where an operator would be able to insert an ad.
Well, this is not done in the Wi-Fi network. It is done in the back office of the service provider. There are systems today that can inject these type of commercials and promotions through the screen. It is done quite a few years already. It's not part of the Wi-Fi network. I was just trying to make an example of how Wi-Fi service providers can try to make money, even though the users, us, we are not that happy to pay anymore for Wi-Fi access.
I see. Okay, we have another question coming in. Is there a central database where the carriers need to register the presence of their APs?
Well, this is an interesting question. If you work in 2.4 and 5 gigahertz bands, which is the unlicensed band, then the answer is no. In most countries in the world, such as North America, if you want to be a businessman, you buy one access point or one base station, you connect it to your own ADSL or cable connectivity for backhaul, and you're automatically a wireless ISP. In North America alone, there are 13,000 such WISP wireless ISPs, and you don't need to register them as far as I know. But we are also selling and marketing a system in 700 megahertz channels. And this is in an area which is sometimes referred to as white space. White space is a domain which is even in lower frequencies, 500, 600 megahertz frequencies. These are frequencies that were used in the past by analog TVs and are being freed these days in North America, but also in Europe, in England, and so on. And these new frequencies, they will be used for wireless connectivity, maybe over Wi-Fi technology, in some areas over LTE technology. Because these frequencies are using channels that are sometimes being used by analog TVs, then there is a specific standard in which when you operate in a specific area, you need to look into a specific database and check and verify that there is no real analog TV over there. There is a protocol for that. It is called the white space frequency,
yes,
which is a little different than what we discussed so far. But going back to the point, 2.4 and 5 gigahertz, in most cases, you don't have to register.
Thank you. There's a tremendous white space effort going on in the U.S. right now with 10 different coordinators. Next question, I know we're running out of time here, so we're going to have to limit these. Is there a solution, I think you've already answered it, that is scalable for small carriers with your system?
Yes, well, the system actually is scalable from very small to very large network because we support an embedded and integral access controller. Then in order to start a network using our system, you just need to buy one unit. And because each unit covers a fairly large area, you have a fairly, let's say, reasonable network even by using one unit. And because we have units in 2.4, but also in 2.4 and 5 gigahertz in the same unit, then you can use the 5 gigahertz for backhauling. So we have an access network and a backhaul equipment in the same device by buying just one unit, and you can start working. And if you grow and grow, you just put additional units with backhaul and so on and so on.
That's a great answer. Next question is your access gateway proprietary or a third-party solution? If so, which is it?
Well, we are using just the open standards like radius and so on. So
okay.
The access gateway can be purchased from us, but you can use any access controller, access gateway, if you need any. As I said, when you have only a small to medium network, like 30, 40, 50 access points, actually we don't even recommend to buy any access controller because you can manage this network by the embedded access controller and by the central network management system. When you grow to hundreds of base stations, then we would recommend to use an access controller, an access gateway, but it can be from us or from any other supplier. We actually have deployments with many other suppliers as well.
Excellent, excellent. Next question is on standards compliance with beamforming. What do you have to say about that? Is your system a standard in beamforming? Such thing exists?
Well, this is a good question. Yeah, this is a good question. First of all, from power point of view, we are working according to the HC standard in HC countries and FCC in FCC countries, such as North America. So, because we are working in an unlicensed band, our system cannot transmit any, power that we want. It is not by doing more power that we reach larger coverage. The other thing is that even though we are using beamforming in our system, it is part of the Wi-Fi standard. So it is an open system. You can buy the CPEs from us, but any Wi-Fi client can work with our system. And this client doesn't even have to know that we are applying beamforming on it. On both ways, downlink and uplink, we are doing all the work in the base station, gaining all these nice dBs without the client being part of this game at all. By the way, looking forward, we would see more and more CPEs supporting 11N standards that do support beamforming, and it will even add a couple of additional dBs to the link budget. But today, I would say most of the clients are not doing any beamforming, but we are doing it for them.
Yeah. 20 dB of beamforming really helps the link budget. This user's left the webinar, so I'll skip on to the next question. This is a good one for you. This Wi-Fi solution is Wavion, and so the question becomes, when will a variant kick off this new product? Well,
Wavion was acquired by Alvarion a couple of months ago. Today, Wavion is a business unit inside Alvarion, and Alvarion is now selling this equipment all over the world.
Good segue to the next question, Ulik. What's the main advantage of the Wavion system in contrast to other Wi-Fi solutions?
I would say the two main things is, one is beamforming, which is up to 8 dB advantage, and the second is advanced interference immunity package of technologies that operates in real time and really addresses the challenges of outer Wi-Fi. I would say these are the two main things. Of course, there are other things such as advanced antenna array and large experience in large outdoor deployments, but the first two I would say are the key.
Okay, I'd say we're going to have to close pretty soon on questions. We're a little bit over our budgeted time here. Trying to pick out the important ones. What is an average cell radius of your Wi-Fi access point when used with a smartphone like an Apple iPhone? And what bit rate can you assume is the cell edge?
This is a good question. The coverage, the cell radius, is usually the weak part, the weak link is the client. Usually the client is weaker from power and also from sensitivity of the radio and antenna. Usually the client is weaker than the base station. So the second thing that determines the radio size is the interference level, the environment. I would say if the client is a smartphone like an Apple device, then it will be a few hundred meters. When I say few, it can be, if we talk about feet, then 100 meters is like 300 feet. So right. If the environment is if the interference level is very high, and we are talking about environment with real high building, then I would say 600 feet, 700 feet. If the environment is fairly clean from interference point of view, and we are talking about suburbs and relatively open area, then it can reach up to 1,500 feet or 2,000 feet.
Okay, we have time for, I think, just one more question, but the good news is we'll be able to do the remainder of the 30 questions that keep coming in. This is wonderful. By email, so please don't feel left out. We started at 9 minutes late. We're going to take this to 11:09, which is now. The last question is, what percentage of total cost of ownership for the home network can an operator save with Wi-Fi offload, if you know?
Well, there are two different flavors of this question. One is the business case by using Wi-Fi to offload, and second one is by using this specific technology versus other technology. So using this specific Wi-Fi technology versus other technologies, from our experience, is about saving about 50% of the CAPEX and the OPEX. Regarding what would the carrier save by using a Wi-Fi in order to offload data from its mobile network, then this is really a case-by-case analysis. In some cases, it is endless, it is infinite, because there is a data congestion, and the carrier sometimes cannot put additional base station in a given area, and cannot acquire additional frequencies in that given area. Therefore, without doing offloading by Wi-Fi or other means like, I don't know, femtocells or stuff like that, there is no other way. So it's not about only saving money. It's about holding your customers from leaving you to the competition. And in some other cases, it is just a question of what will cost less, putting another Wi-Fi base station or putting another 3G base station. In this case, I can say that Wi-Fi equipment cost is about 20–25% of equivalent mobile network cost, and you have these figures.
Wonderful, wonderful. Well, Ulik, I'd like to thank you for a wonderful presentation today, and thank Wavion and Wavion for one of the finest presentations we've seen in a while. And for our audience, thank you for joining today. If we didn't get to your question, you will be emailed the link. Actually, you'll all receive a link for the replay anyway. And you may want to email Ulik directly. Also, our administrative staff at WCAI has copies of all the questions that came in today. This has been an overwhelming response, and I'd like to thank you all for joining. Have a wonderful day, and Ulik, thanks again once more. Wonderful job.
Thank you very much, Harry, for leading us through this process.
Thank you. Have a wonderful day, all.
Thank you.